Hey Algebra 1, this video is a quick introduction on how to write in set builder notation. This will help us identify what the domain and range are for certain graphs based on their properties and key features. But for right now, let's focus on set builder notation. First thing we want to know is when we build in set builder notation, or when we write about a set of numbers in set builder notation, it looks something like this. So we have these curly brackets on both sides here. That implies a set of numbers. Okay, so the curly brackets always imply a set of numbers. Okay, so we're going to call this set. Okay, that's what that implies. The next thing we notice is that there's a variable as the first thing we see here inside the curly brackets. Those are all numbers defined as x. Okay, this vertical line here is just a condition. It's basically such that. Okay, and then this is my qualifier for whatever x is. So in this case, x is greater than 0 or all my numbers x that are positive. So putting this all together, we have the set of all numbers x such that x is greater than 0 or x is positive. Okay, so let's go ahead and translate through a couple of these. Okay, let's say we have this. So this is the set of y and then we have this such that this vertical bar here, and then we have this compound inequality 0 less than y less than 12. So this is basically telling me that y is all numbers, or this is the set of all numbers of y such that y is between 0 and 12. Okay. Once again, we want to look at mostly this part right here, this 0 less than y less than 12, that and inequality. That tells me that y is just all these numbers. If we're looking at a set of y numbers, this is all my numbers between 0 and 12. And once again, because they're less than and not less than or equal to, we don't include 0 and 12 in these numbers, or in this set, I should say. The next one I want to look at is a little bit different. We've got the curly brackets again with the variable c, but we have this script r here. This script r really means all real numbers, but we don't include 0. So the way I would write this is the set of all numbers c such that c is not equal to 0. So if it's all real numbers, any number you can think of, that's included here, but we're not going to include 0 in there. Okay. Last one I want to take a look at is working backwards, creating set notation from a set of numbers. Okay, so once again, another compound inequality, 7 less than x less than 20. All right, so that's all my numbers between 7 and 20, not including them. The way we would build that is just curly bracket x such that x is between 7 and 20. Pretty simple. But if we have something like this, set of all numbers d such that d is not equal to 10, we'd do, once again, we'd have the set of, with the curly brackets, we'd have d vertical line for such that, and then my r implying all real numbers where d is not equal to 10. So we exclude 10 from that set of numbers. And last but not least, set of all numbers y such that y is all real numbers. Well, that would just be this. So curly bracket y such that we have all real numbers here. Okay. So once again, this is important for us to use when building up the set of numbers that include our domain and range for a graph. You'll see that in the next video. Stay tuned for that.